we have Curtis Chambers here, who is the Director of Engineering at Uber, and he's going to be talking a little bit about data science. So I will give it up to him with the side note that Curtis just got married a couple weeks ago, so big congratulations to him. His lovely wife sitting up here in the second row. And I'll let Curtis take it over.
Good. Cool. So, as Holly said, I'm the Director of Engineering at Uber. I've been there almost 3 years. Good. Stand over here.
Now I can't see the slides.
Oh, perfect. Totally. It's still feedback. Okay. Cool. So, it's good? So, yeah, I've been at Uber for almost 3 years. I joined, I think we were only 7 people when I joined. We were a very small company. We had no idea what we were doing. This talk, I kind of wanted to talk a little bit about the science of Uber. I think people know what we do for the most part as connecting people with rides, but there's a lot of things that happen on the back end to kind of power all of that. And I brought a couple of the data scientists from Uber here today so that people can talk to them afterwards, talk about some of these projects. I said, what is Uber? So I hope everybody here knows what it is, but if not, here's the quick 5-second tour. Essentially, it's a mobile application. You can push a button, request a car, and it comes and picks you up. We connect you with a licensed and insured driver that goes ahead and takes you where you want to go. It's very simple, very clean. Oh, really? Oh, well, we can fix that. But the story of the founding, I think, is actually really interesting. If you've seen my talks before, I love telling stories and what happened. How did we get here? So Uber was actually started by Travis Kalanick and Garrett Camp. So I think this is from South by Southwest. But they actually created Uber not to solve global transportation, as we kind of are trying to do now, but they just wanted to get a ride on a Friday night. Anybody that lives here knows that it's impossible to get a taxi on a Friday or Saturday night. It's just not going to happen. So they had this crazy idea of, let's just buy a car, put it in a garage, and hire somebody to drive us around, just the two of them, whenever they needed them. He's like, either I'm going somewhere, or you're going somewhere, or we're going to a party together, so let's just do this. And as more and more of their friends, such as myself, were like, dude, let me get access to this, kept saying, I want to use this service, they're like, this might be like a legit business. So a few months later, I joined. This is the picture from when I joined, December 2010. This was the entire company, and now we're up to like almost 400 employees or something like that. So this was the company, half engineering, and this was our stack. It was nice. Yeah. So simple. The old app. This is like retro style. And there's a lot of inherent problems with this. I won't get into it in this talk, but this doesn't scale, especially for a real-time dispatch system. So we moved from this to this. This is our current architecture. There's a lot more going on now. We have to have all this going on because now we're in 18 countries, we're in 45 cities, we're in every time zone and 12-ish languages. We're just going all over the place, so you have to build out a lot of infrastructure to power that. So a little bit about our engineering before we jump into the science team piece of it. Oh wait, I have my slides a little bit out of order. So now the engineering team has grown from 4 when I joined to about 70 engineers. Almost the entire stack is Python and JavaScript. We have a lot of services we built in Python. We have Node.js dispatch. We have Backbone and Chaplin on our front-end tools that we build. With the exception of the mobile apps, I'd say 99% of our stack falls into that. We now use Postgres with Postgis on top. That was an interesting transition. We were running on MySQL for 2 years, and just this January we migrated to Postgres with 0 downtime. And there's probably an hour-long talk just on how to migrate from MySQL to Postgres on a live production system with 0 downtime. I think there is a talk about that online that Evan gave. Since we're at Atlassian, I figured I'd talk about the Atlassian products we use. We use HipChat extensively. We're exploring Jira, see if we like it for bug fixing, or bug tracking, I should say. And we have some open source projects that we've kind of put out there, hope people can play with, contribute back to, and we're trying to maintain them, but we're just kind of constantly working on all kinds of stuff, so it's kind of tough. But anyway, this was the slide that was supposed to be next. So Uber started not as what it is now. Now I think this is actually more of what our mission is. It's a cross between lifestyle and logistics. Lifestyle being quality, and logistics being efficiency and reliability. One way we say it is we want to give everyone a reliable, high-quality ride at every price point. That is also our slogan of everyone's private driver. So we've gone beyond just the private town car business to like low-cost Uber, like UberX, taxis, SUVs. We have boats in Amsterdam and Sydney. We had Uber Chopper in New York, where you could take a helicopter from Manhattan to the Hamptons. We had on-demand barbecue sandwiches at South by for 2 years. We had on-demand mariachi bands on Cinco de Mayo, on-demand roses on Valentine's Day. We're just trying all these different crazy things. What can we do with this logistics framework that we've built up? So it truly is the cross between lifestyle and logistics, and the science team at Uber powers a lot of those logistics and some of the lifestyle as well. So first we'll get into the logistics. So to me, logistics is efficiency and reliability. I think these are the two things that we basically strive to achieve no matter what. Like these are the core two values. And just talking about efficiency here, like one example of efficiency and how we try to make the system more efficient is something called supply positioning that Henry right here worked on. And when we started with supply positioning, this is actually when Henry first started. First task was like, how can we optimize the supply so that all the drivers are driving a passenger around constantly? How can we increase the number of minutes per hour they have someone in their car and thus increase their revenue per hour? So we thought, if we actually know what's going to happen, it makes the problem much easier. So first we were like, demand prediction. How much demand are we going to see? And if we know how much demand there is, then we can onboard enough cars to satisfy that demand. So supply matching, how many cars do we need? And then finally, supply positioning is like, where should those cars be so that they, have very low ETAs? Like, I think when we started, our average ETA was like 11 minutes. And now in San Francisco, I think it's 2 minutes and 18 seconds. It's crazy. Last weekend, I pushed the button and the car was outside 15 seconds later. I wasn't even ready. I was like, where are my shoes? So this was kind of the initial thing that we tried to do. And we thought, OK, this will be great. But what Henry realized, I think, as we built this was that supply matching doesn't really matter in some regards. Like, we really just need to know where the demand is going to be. So demand prediction isn't how much demand we will see, it's how much demand where we will see it. And we don't need to predict it a week ahead of time. We need to predict it in the next 15 to 30 minutes so that people can accordingly position themselves to minimize those ETAs. So we focus mostly on demand prediction and real-time demand prediction, not future demand prediction, and then real-time supply positioning. Where should we put these cars? And I think Henry, when you heard supply positioning, thought about this, like a heat map. This is where the cars should go in the hottest areas, and then they shouldn't be over here. And so that's kind of what we based it off of originally. So the drivers get this real-time heat map that's kind of layered of like, here's where the demand is going to be, and then layered on top is like, here's where the open cars are, the anti-heat, and then gives you the residual demand. Where should I go if I want to be able to get a trip right now? So we experimented with a wide variety of ways to present this to drivers, neighborhood-based, pure heat maps, a combination of neighborhood and heat maps. Just show them where all the other drivers are and let them figure it out. There's all kinds of things you can do here. And so we're still constantly testing and iterating and trying to figure out what makes it so that we can minimize the ETA and maximize the driver revenue. So it comes down to that core principle of efficiency. And there's a lot of other things we do with efficiency as well, but that's, I think, like a perfect example of one of the major things we do to make sure the entire system is as efficient as possible. So reliability, there's two things that really contribute to reliability. One is ETAs, how long does it take for the driver to pick you up after you request? And two, everyone's favorite, surge pricing. So we'll talk about that in a bit. But ETAs are interesting. So when we first launched New York, we used Google as our ETA engine, and it would say like to go from the Lower East Side to the Upper West Side, it's like, oh yeah, it's like 10 minutes. And it's like, that's not 10 minutes. The traffic in Manhattan is horrendous. They were using kind of algorithmic decisions based on how wide the street is and how fast cars can go on it and traffic lights and these things. But what we ended up doing is building our own ETA engine based off of our actual driver's driving history. We collect all the GPS points, the routes, the speeds, the lat longs. We know all this. We know how people move around the city. So we built our own engine, and this is actually a graph from like 2 years ago. But we were basically had about half the mean squared error of Google, and I think now it's even lower. But actually, Google in the last 2 years has improved a lot too, so we should probably measure this again. So that's why we built our own ETA engine, because we needed to, because a customer would expect 10 minutes, and then it would take 30 minutes, and then your reliability is gone. Nobody can trust what it says. They just don't believe in you, and so we had to really get that down to the point where it's like a minute or two off of what the actuality was. This was actually, I think, Henry's coding challenge when he interviewed with us, but he created this really awesome heat map based on where in San Francisco you are and what the expected ETA is. And you can see, it's kind of interesting how it outlines the streets, and you can see which areas the cars kind of wait in. So these are some of the interesting visualizations that the science team does as well that help the internal operations teams know how to manage their supply. Another one of our data scientists made, this was a kind of where people open the app. And you can kind of see the hot spots in the city, and it kind of, again, draws the lines of the streets. It creates some really beautiful visualizations that actually are useful too. So everyone's favorite, surge pricing. I'm sure some of you have seen this screen at some point on Friday or Saturday night. And people hate this because they get charged more, but the key to it is that it actually increases reliability. We don't do it because we're like, hey, let's just charge more, it's going to be awesome. We do it because we don't have enough supply to satisfy the demand. It's when those supply and demand curves get out of whack that we have to do this to basically rein in demand to keep them in check. And so what this means is that you actually are able to get a ride instead of not. I had a friend that was like, I couldn't get a taxi, I couldn't get a Lyft, I couldn't get a sidecar, and then Uber surged me, and it's like, but at least you could get a ride. You couldn't get a ride on any of those other places. And so that's kind of the point behind this. And we learned a lot of lessons over the years trying to tweak this so that people truly understand what they're going to pay. We're all about transparency and openness and trying to make sure that people understand what's happening. So messaging matters. This was our original surge screen, and for New Year's Eve 2012. And so have a few beers and then try and see what you're going to be charged here. New Year's Eve, everyone is wasted, and they click on this and they're like, okay, give me a car, and they don't realize I'm about to get screwed. And so we saw this problem where as the prices go up, users request more? That doesn't make any sense. As the prices go up, the users should request less. They should be like, that's too expensive, I'm not going to do that. We thought users were pricing elastic. And so it's cool. But it's actually the messaging. So we switched from this screen, which it takes you a while to figure out the multiplier, and there's nothing around dollars, to this screen, which is right in your face. You're going to get charged this much. Here's the minimum fare. Here's the minutes per mile. And the support complaints went down an order of magnitude. People understood it. They got it. They still don't like it, but at least you can get a ride. So that's kind of the point of that. And we introduced this screen, and as we expect, as prices increase, the people actually click OK less and less often. And all this is based off of utilization data, right? So here's a chart. Oh, this is weird. It didn't show any of my other lines, but a chart of utilization over time. And so at this point, you're seeing that almost all of our cars are used. And so what happens is surge kicks in at certain points, and basically kind of it'll lower the demand curve so less cars are used and we have more supply available. So the chart didn't come out right, but anyway. So I talk about logistics. Then there's also lifestyle, the quality aspect. What makes for a good user experience? And a lot of it is the quality of the driver, the quality of the car, their knowledge of the city. And these are all things we do when we onboard drivers that our operations team tests for and measures and constantly iterates on. The 5-star rating system that kind of helps us determine who's a good or a bad driver. But there's a lot of science that actually powers this too. So, your ETA is in the app, powered by science. The surge pricing is all powered by them. Map matching is fascinating. Back in December, we launched our new app, and one of the major things that we thought was really cool, and I think people noticed it too, is that the cars now animate in real time, and you can watch them as they're driving. And they snap to the streets, and they have acceleration and all this crazy stuff. Occasionally they'll do helicopters, I don't know what that's all about. But this took a long time to build and was really hard because GPS is very lossy, right? The GPS points, especially from an iPhone, kind of bounce around the streets, they bounce off buildings, they kind of cut through blocks. So Matt Sweeney, who actually runs our science team, built this for the most part by himself. He worked with some other teams on it as well, but he kind of like drove this project because we thought it would be cool. It'd be like playing Grand Theft Auto on your phone, like the original one that's top down and you're driving around. So that's another thing that the science team built. Another one is fare estimates. You know, for a long time, users were sometimes surprised at how much they were charged. And so we wanted to give them an ability to know, if you're going from this point to this point, here's the range of prices it'll be. And that's actually kind of a difficult thing to do, because you don't know what the traffic will be like, the demand patterns, this and that. So this uses all of our historical data as well as some routing engine data to come up with a really accurate estimate and allow users to know what are they getting into. Like, because you know, there's not like a taxi, there's a meter, you can see it kind of ticking up, or these sorts of things. So, so this just, I think, all delivers a good user experience where people understand what's happening, and it's just a really nice service. So, what's next? Like, we've done all this other stuff. What's the science team up to now? Well, honestly, I wish they were up to this, on-demand time machines. This is yet another thing we did last weekend, where we had on-demand DeLoreans available in San Francisco. And you could push a button and a DeLorean would show up and you could take a ride. But there's actually a lot of really interesting things that I think we're doing, one of which Lion, who's also here somewhere, built. We kind of internally call it Masudi. And this, I think, is actually really fascinating. It's an end-to-end geographic data playback system using GeoJSON. And essentially, it has all the live data and caching servers and then an archive server for the entire history of the data. And a very, very simple interface that allows you to basically replay data on a map. It's a responsive web application. It works on mobile. It works on desktop. You can replay things at different speeds. So we can actually do a lot of interesting analysis that we couldn't do before. So one example is like this small bit of code generates this on like a canvas. And so basically, I think this shows ETAs. Actually, this is ETAs kind of drawn out based on where people opened the app and what their experience was. And then you could replay it and the dots would move over time. So there's a lot of interesting uses for this. One is you can watch all the cars moving in real time on the map, where they're going, what they're doing. This helps the operations managers, you know, manage their supply. How much open supply do I have? Where is it? You know, I need to text all the drivers and tell them to go here because a concert's getting out or a game is happening. Another is this, which kind of shows their coverage area, like which parts of the city are covered right now based on the dispatch radius of the car. And so we can see kind of what is our true real-time availability in dispatch zones. Here's another one, again, just replaying data of SF eyeball conversion data. We call it SF eyeball conversion. Eyeballs when somebody opens the app, and then how many people open the app convert to a ride. And you can kind of see, again, like where problem areas are, like, is this a problem or is this the problem? And this is, our operations teams just love this stuff. And those heat maps we showed earlier are also powered by this as well. So it generates, you know, the neighborhood-specific heat maps, things like that. So that's kind of a brief overview of kind of some of the science projects that Uber's working on. We have a lot of other things that we're doing too, but I just want to kind of throw out there that, like, you know, I think a lot of people think we're just an app. We're a mobile app, you push a button and a car shows up and there's not much to it. But out of those 70 engineers, only 6 of them are mobile engineers. We have a huge data science team, a huge analytics team, a huge internal tools team. That's probably like a third of the engineers is just internal tools for the operations folks. And yeah, so that's kind of the magic that powers Uber. I hope everyone has a magical experience with Uber because of all of this. And that's pretty much it. Open for questions.
So yeah, we're going to open it up to any questions that you guys have. I guess I will introduce my buddy Colin here. He's going to run around with the mic and try to get to you guys as fast as he can. He took his shoes off to make sure he could do that, or something of the sort. So yeah, all right.
So I used to Uber in Manhattan and San Francisco, and I love it. My daughter went to school in Boston, taking the SAT. And she said, "Oh, I couldn't get an SAT past the year need, and I need to go to Boston." I said, "Oh, just take Uber." Because I need to be there at the same time. I can't order Uber in advance. So you can order Uber in Saturday at 15 for my SAT exam.
So basically, when can you reserve a car ahead of time?
Yeah.
Reservations question, it's quite common. Our general response to that is if the science team can be as perfect as we think they can, we can eliminate the need for the concept of reservations. Reservations exist because typically people aren't good at managing supply and demand. You know, they're like, we need to do this so we know ahead of time what to plan for. We're trying to do this in real time, like actually manage the supply and demand in real time, and then Surge helps, you know, keep that in check when we can't do it at normal prices. So there's no real plans for doing reservations, just because we actually think that's somewhat of an outmoded concept if we succeed at what we're trying to do here. It's very infrequent. I don't think I've had a time in the past 2 years where I tried to get a car and wasn't able to. Sometimes I get surged, but I've always been able to. And so, yeah, that's kind of where.
The penalty can be huge, right?
Oh, yeah.
I'm going to SFO in San Carlos,
Mhm.
and I know I have to be there, and I never use Uber because I always, when I call before I can get a cab.
Do they always show up?
But I'm worried that if I wait till Saturday and I call Uber,
Yeah. In some of our less mature markets, that's a possibility. In San Francisco in the early days, like 3 years ago, that was definitely happening a lot. But as the market becomes more mature, that becomes less and less of an issue. So, yeah. Or,
Hi, well, Uber, thanks for coming. Do you guys use your science team to help determine what markets to spread into? Like, what are the determining factors that you use to determine this is the next city that we're going to go after?
yeah. I think nowadays we have a launch team that kind of works on that. They work on launching markets all over the world, and they're very good at doing the analysis to figure out what should the next markets be. And to be honest, the majority of that decision now falls under sort of legal and payment processing issues, because most of our markets are international, and with different currencies, different cultures, there's all kinds of things to look into besides, you know, how big is the market and these sorts of things. It's like, can we even do that? You know, we're very illegal in certain places, such as like Vegas. So they kind of work on that first. In the early days, though, the science team definitely did that before we had a launch team. I remember when we were launching New York, we were like, oh, there's so many cabs in Manhattan. Like, let's just launch in Brooklyn, because Brooklyn, it's impossible to find a cab. That's going to make way more sense. Then we looked at the data of where people were opening the app and trying to get a car before we even launched there, and all of the app opens were in Manhattan. There was barely any in Brooklyn. And so that changed our entire launch strategy of launching in Brooklyn as an alternative to cabs to just launching in Manhattan as like, well, I guess an alternative to cabs. But yeah, that switch in strategy actually helped us succeed tremendously. So that was something that the science team did in the very early days when we launched New York, which was our second city.
Thanks for coming here. So for a few weeks ago, I saw a headline in the criticism day that Google has invested a lot into Uber. There's a lot of speculation about driverless cars and potentially a partnership there. So I wanted to see if you can comment on Google's investment or Uber and driverless cars in the future.
Yeah, TechCrunch wrote an amazing fake article about us acquiring 10,000 of those driverless cars. If only that were true. But I think Google's investment is definitely a strategic one. I mean, there's a lot of overlap in things that they do and what we do. You know, things like Android, Maps. Like, we're building a lot of the things that they've built as well, but more specific to our use case. And, you know, perhaps even driverless cars at some point, but they're nowhere near ready for production yet. So, you know, maybe that's like a 10-year thing. It's one, very far off on the technology, and two, very far off on the regulatory. Like, if you think Uber getting regulatory battles is bad, self-driving cars is going to be a total nightmare in terms of liability insurance and who's responsible when a self-driving car hits you. It was the car's fault. Oh, okay. So.
Hi, can you talk more about metrics that you use to determine exactly what the search bar should be?
Yeah, so I wish Kevin Novak were here. He kind of owns dynamic pricing and how it works. But he's actually giving a talk at Google right now in Mountain View. But yeah, essentially it's purely based on the utilization of cars. So, and it's configured by the cities themselves, but it's a mechanism that kicks in automatically, and it goes up and down based on the utilization. So, if we're half utilized, totally fine. But once we get up to maybe 80 or 90% of cars are taken, depending on the city, we might, up it a notch and see if it can cull demand and kind of stop it from hitting 100 and there's no cars available. We do it step by step. Right now, we mostly do steps of 25% increases in price, and it step changes every 5 minutes. But that's totally configurable. We can do it more frequently, less frequently. The key is that when you push the button, you lock in that price, and that's what you're charged. And that's how it works now. In the early days when we were just hacking it, trying to get it together, as you see, it looks terrible and it works terrible. Now it's much more robust and works well.
I also love Uber. I had a question about retention of drivers. If you have any insights as to science teams, something like year-on-year growth, month-on-month growth. And the reason I'm asking is actually I did an Uber ride in Boston, actually very good. But this guy had a huge business outside of Uber, and he said, I only use it when I'm slow.
Yeah.
So I think any of us who are, in the kind of intermediate marketplace business model, we have this concern on how we can send the vendors in the marketplace to stay with us, outside of us. So I was wondering if you could talk about plans and what have you seen, our drivers, reaching out to the point of
Yeah. Well, it's interesting because what your driver told you is actually our original pitch when we started Uber. Like we didn't think this was going to be a full-time job for our drivers. It's more like the driver drives the CEO in the morning and then drives him home at night, but what does he do during the 8 hours in between? Let's fill up that empty time. And so he still has his private clients. And but as we've been able to deliver more and more demand, and especially on these efficiency gains, these drivers are making more money with us than they've made with their private clients. And so more and more of the drivers start that way, and then once they see how much money they make, they just more and more come to us, and we have a ton of full-time drivers that work for us. We even have some crazy stories about our early drivers. One of our early drivers, Riyadh, one of our engineers flagged him down kind of like illegally in the early days of Uber. It was like, hey, I need a ride home. And he pitched him on Uber while drunk in the car. And when he got out of the car, he's like, yeah, take my card, call me back. He ended up becoming one of our drivers, and he was just barely scraping by. He was like, I barely can afford this car. I'm living in a tiny little studio apartment. And now he's grown his fleet to 15 cars and bought this big house, and he named his firstborn after that engineer that flagged him down, Ryan, because he's like, you totally changed my life. This is amazing. And so we see more and more of that where we have partners that just have grown their fleets. We don't own and operate any of the cars. We work with existing service providers. And so we partner with them, and then they're able to grow their fleets. So I know one of the guys has 15 cars, all these drivers that work for him. So it's like empowering small business growth. It's actually kind of interesting. I don't think a lot of people know that about Uber either. They think we kind of own and operate the cars and drivers, but it's really just they're contractors, and we drive demand at them. We're more like Expedia than we are like Delta or something like that.
All right, so I know you're pretty far removed from this at this point, but if you were to bootstrap a location-based startup today, which platform would you develop for? Which tool would you be using? Any of those created by Uber? Some open source
I think it really depends on the problem. The main reason we ended up rebuilding our dispatch system away from a LAMP stack to Node.js was because we had all these kind of double dispatch problems, locking in concurrency on the drivers. So that particular architecture, the single-threaded nature of it, made sense for what we were trying to do. But yeah, I am kind of far removed from it at this point. But we try to stay relatively cutting edge, and we're always playing with the hot new shiny toy, and then sometimes we're like, this is a terrible shiny toy like MongoDB, or this is like an okay one. So yeah. The MongoDB thing is it couldn't handle our write volume, so we had to ban it.
All right. I would be interested in what difficulties you are facing with local governments when entering your market. Really interesting stories behind it.
Oh, the legal team doesn't want me to talk about that. I think there's been a lot of really interesting ones. My favorite, though, or not even favorite, but the thing that blows my mind is some of the people that are regulators for this industry, or even regulating us, don't purely understand the technology they're regulating. I mean, you could see that with, I mean, that's, I guess, always true, right? The whole Senator Ted Stevens series of tubes, that's the guy regulating the internet. And we see similar things where people like try and regulate us, and they're like, what's an iPhone? Like, what? And so we show them, this is an iPhone, you push a button, and so those are the most funny things to me about that. It's like, you know, like if I were a politician, I'd want to like truly understand the thing that I was actually passing laws for. So it's not always the case. But all the cities are very different. All the countries are very different. You know, one of the stranger ones, I think it was Taipei, where if a customer requests a receipt, you have to make a written receipt on government-issued paper with a unique identifier on that paper, mail it to their physical home address. And the reason is because that unique identifier on the paper is a lottery ticket. So every transaction you do is an entry into the lottery, so all the customers ask for it. And it's their way of making sure all the business is done above the board by making everyone ask for receipts. And it's like, oh, because we just do email receipts, right? Like, so these are some interesting things that you discover when you go international or go to different places that have these interesting things. So
I think there's obviously a lot of things that data can help solve. Like, what are some of the things that you found that you really couldn't solve with data? That you tried to apply a lot of data that you had and it just didn't work, or you solved for the solution?
Yeah, I mean, I think even related to some of the supply positioning stuff, and you know, initially we thought, oh, maybe we should like even schedule drivers, because then we can control exactly how many there will be if we can predict demand. But it turns out that, you know, people are smart, they know what to do. We just kind of let it be a free-for-all, and the drivers kind of self-manage themselves to working at the busy times, the peak times, and not working during the slow times. They just know those demand patterns. And so we were like, wow, we really don't need to solve this because their brains solved it already. So I think that's kind of the most interesting learning is, I think we have this tendency to think, oh, we can, you know, have this perfect system, you know, managing all these agents moving around in a place, and it's like, or you just let it run free and magic happens.
With the data, philosophical question of Uber hasn't necessarily had the most search pricing when revenue generating product that comes from data. How do you guys talk about looking at from two sides? One, recruiting people to come in and people and actual
Yeah, I think that's what this talk's all about. Like, look at all the cool data products we're building that make this thing work.
The second question is with respect to revenue. So it sounds like there's maybe research pricing. Do you have other things that come to mind that you tried and didn't work, where we thought, oh, this actually would be great, you know, as we were first discovering your business model 2 years ago, and starting to things that we would schedule
Yeah. Yeah, I mean, it's trying to think, like, when we set our pricing, we kind of just took a wild guess and just made up some numbers. There wasn't any real, like, science behind that, because we didn't know any better. But yeah, I think surge is really the only thing that kind of moves the needle a lot. We don't like to change the base price because we don't want to confuse people. We want it to be a consistent experience. And when we do change it, we announce it very publicly. Like, UberX is now 25% cheaper than a taxi. So yeah, I don't think we've experimented much on things like that. But we are starting to experiment more on like how we can get more viral growth and these sorts of things, which will eventually lead to more revenue growth and more users and these sorts of things like that.
Anything on the driver side, like some drivers get or some like benefits by
We've done some things around like bonuses for drivers if they, you know, I think like for New Year's Eve, we're like, if you do so many trips, we'll give you a little bit extra. Things like that, but they don't help the revenue. They actually help the driver. They help the driver's revenue, but not our revenue. But that's how we guarantee supply on a night like New Year's Eve when a driver can charge $1,000 for driving somebody around. It's crazy. Like, that's why we have to have such high surge rates on New Year's Eve, because otherwise there would be 0 cars on. is just a very special night for us.
Hi, my name is Hercules from Studio Technologies. Could you tell us which one of your competitors are representing Regis Square and why?
That's a good question. I mean, in the early days, there was a lot of clones of exactly what we did, which was like black town car services, and they've mostly fizzled out and died. But then there's been sort of clones for taxi services. But again, they've had a hard time. Like, taxi is this interesting market in that it's artificially constrained by the government. Like, there's only 1,500 taxis in San Francisco, and there's been 1,500 for the past 50 years, even though the city's grown. And so those startups can't play with the economics like we can. They can't play with how many cars are there. They can't play with the price because it's regulated by the government. So like, they don't have those knobs to turn to really make a great product. But then there's interesting ones like the peer-to-peer startups that are coming up and like having people, drive you around, and those are, for the most part, completely unregulated. So there's been some recent things in California where they, require background checks and these sorts of things, but that's technically only legal in California. So I think most of them will have a decently hard time expanding outside of California, but it remains to be seen. Like, sometimes governments don't even enforce this stuff. So.
You mentioned that you are developing on real-time demand. What is demand forecast? What goes into those forecasts? What are the inputs and how real-time they are?
Henry here would be the best to answer that, but I'm going to take a wild stab at it.
I'll try.
Yeah, that's fine. I mean, I think it takes a lot into historical demand patterns, like how much do we usually see on a Friday at 4 p.m. in this particular neighborhood. It also is a lot with how many people have opened the app in the last 15 to 30 minutes, because I think how many people open the app is somewhat of a leading indicator of how many people are going to open the app in the future, in the very near future. There's probably other things that I don't know about.
Yeah, I want to say the part of map prediction that makes us somewhat unique to a lot of spatial map prediction. Right? So a lot of people just start flying on the map we demand. Okay, so for many people, map prediction is just taking last week's demand, we wake up training before they go. For us, it's a lot more about, hey, guess what? Pattern, the demand pattern is there, so it's significantly different than it is downtown. So it becomes a big question of how do you cluster, how do you generate these areas if you want to do that. And from there, then do prediction on top. So for us, it's actually a lot of clustering, a lot of geospatial clustering, and then after that, it comes after that, you just basically go everywhere. If you want like a very near-term prediction, yeah, just use the rolling window exponential. Yeah, just use any sort of regression rolling by don't get it. That's pretty much the pretty much one for you.
We have two more like that. Have you done any analysis into what leads users to churn, and if so, how did you come to those conclusions?
Yeah, we have a very low churn rate, but I think for the most part, a lot of people churned in the early days because we were just too expensive. Like, price was the number one. Well, actually, I'd say there's probably two indicators of why users churn. One is price, and that was when we only had the expensive town car product. Now that we have UberX, the churn rate is dramatically lower. And two, a lot of people travel a lot, and they'll come visit San Francisco, use us, and then go back home to Houston where we don't exist. And so we consider them churned users, but when we really dove into it and looked at it, it's because they live in a place we don't operate in. And so that's kind of why we need to just expand everywhere in the globe, because we want to make this a service that works in any city you go to in the world. And then we can avoid all those churned users.
It was pretty convenient when you started talking about Houston there. It's really how quickly we're growing internationally. Are there certain growth rates that you see going and found that the growth rate is slower than that? What's relevant to the right there?
The one that surprised me the most was Los Angeles. I'm from San Diego, and I've gone to LA all the time. I've never once used a taxi in Los Angeles, or a bus for that matter. Like, you just drive in Los Angeles. And it's I think, been our fastest growing city to date, which is kind of crazy to me. Like, who doesn't just drive everywhere in Los Angeles? So that's been, I think, the most surprising in that, you know, so it's kind of interesting. We went to New York as our second city because we're like, that's the biggest market. We got to get in there. Then we went to Seattle as our third city, which was kind of a weird choice. And the main reason we did that was because we noticed in San Francisco that the demand patterns correlate very heavily with rain. We're like, Seattle's perfect. Like, it rains all the time. We're just going to print money. This is going to be great. But it turns out the people that live in Seattle don't care about the rain. They just walk in it. They don't even use umbrellas. And so that was kind of fun. But Los Angeles doesn't make any sense to me at all, but it's been amazing.
Okay, great. So huge thank you to Curtis for coming out here. You guys have lots of some data scientists.
Yeah, Henry here.
Can you guys stand up with your Curtis? And you guys will do your just like.
So Henry was our very first data scientist, and Alain is here, and he's actually the one building that Masudi product, the real-time geospatial playback engine. So brought these two guys with me to talk about all that cool stuff.
Fantastic. Well, don't hang out around here while we get back and drink some beers, and Curtis is going to hang around for a little bit as well. A couple of other things. This talk is going to be available tomorrow on the DevDev website. So if you guys want to send it to anybody or watch it again because it's so amazing, then you'll be free to do so around noon tomorrow. Another thing, fun fact, we're hiring a data scientist. So if you're interested, this gentleman, Chris, is the guy to talk to. He's going to be hanging out by the wine after this. So go find him or find him at Atlassian to chat to about that. Quick question for you guys. How many of you guys use Atlassian products or have used them? Oh, that's amazing. That's what I like to see. So we are getting really excited for our upcoming user conference. It's October 1st through 3rd Summit. If you have any questions about that, we've got these lovely postcards hanging out, and you can pick one of these up for some information, or you can ask any Atlassian. And if you're Atlassian, you like stand up or give away so everybody knows who you are. Yeah. So you can find any of us and come talk to us about any questions you have about Atlassian, about our conference, and of course about DevDen. Yeah, thank you guys so much for coming. Oh, one more thing, actually. Our next DevDen Tech Talk is going to be on November 5th. We have Jordan Benson coming from Nura. He's a software psychologist. He's actually in the back if you want to lawyer too. And then on January 28th, we have Yehuda Katz coming to speak. So yeah, if you have any questions, come find us. Thank you so much. And we'll see you at the next DevDen.
All right.